Introducing the TPI-1001B RF signal generator. In this video, we're going to show the features and functions of the TPI-1001 signal generator and the TPI-Link software that configures it. The TPI-1001 is based on the analog device's ADF4351 wideband synthesizer. The qualities we look for in a top-shelf signal generator are ultra-wide frequency range, a wide output range, a stable time base, low noise and jitter, and have it be capable of a wide range of tests and be well calibrated. The TPI-1001 meets all these criteria, with a frequency range of 35 MHz to 4.4 GHz. Its output range is plus 10 dBm down to negative 90 dBm. It uses a TCXO for the time base and achieves a 1.5 ppm stability. It has jitter of less than 0.4 ps RMS, and it's calibrated so that most of the measurements are within plus or minus 0.6 dB. And the TP-1001 has extensive testing capabilities. Let's start with a look at the unit itself. First, on the right side is the RF detector input. It's an SMA connector. It can handle plus 10 dBm maximum. Do not put any DC on this line. And that is used usually in conjunction with a directional coupler to do tests such as VSWR, return loss, antenna resonance, etc. Next is the trigger output. It's a BNC connector, and it is configurable in the TPI-Link software to provide a voltage output when certain conditions are met inside of the TPI-1001. We have two LEDs after that, red and green. The first one is RF on-off, and the second is the general power LED. We have two push-button switches right over here. The first one is RF on and off, and remember, when you're out in the field operating this autonomously, it'd be nice to be able to turn that RF on and off. The next is totally configurable inside the TP-Link software and then held inside the non-volatile memory so that you can control one of the other functions when out in the field and not hooked to a PC. And of course, most importantly, is the SMA connector for RF output here. I have a little dummy load connected to it, and remember, it should be connected to some kind of termination. On the left side of the unit, we first have the auxiliary input, and this is for a voltage from -5 to +5 volts. It's used to trigger a number of functions inside the unit when configured by the TPI-Link software. Next is the 10 MHz reference output. That is so that you can slave other equipment to the clock from inside this synthesizer, or from a GPS discipline clock that you're feeding through this synthesizer. Next, we have a USB connection, and that is used to power the unit and also talk to the TPI-Link software. The unit requires 350 milliamps to run and can run off of a portable battery pack. Next is the FM input, and that's between 100 millivolts and 10 volts. You have to have the FM enabled on the TP-Link software for it to work, and remember that the voltage coming in is going to determine the deviation of the FM signal. Last on this side is the 10 MHz external reference in, so if you do have a GPS discipline clock, you can put it into this input and have extra accuracy. TPI-Link is the PC-based programming software for the TPI signal generators. It's provided free with the units, and updates are provided without cost. You can use the signal generator while controlling it from the TPI-Link software, but the settings at any given time are being held in non-volatile memory inside the signal generator, and it powers up with the last settings used. You also have the programmable button on the generator's front to initiate pre-programmed scripts or other functions while you operate it autonomously in the field. With a typical USB battery pack, it'll run for hours. Once you have your unit connected to the TPI-Link software, your first tab is going to be the generator tab, and on the top left you'll see we have the frequency display window. Right under that is the increment that you can change to any increment you'd like when you click on the arrows to the right to quickly shift frequency. Right under that, in the green boxes, we have 6 memories for commonly used frequencies. To save frequencies into one of the 6 memories, or in one of the 6 output level memories on the right, it's the same as an auto radio. Whatever frequency is displayed in the frequency window, or output level in this box here, place the cursor into that memory slot, hold down your left mouse button for a few seconds, and it'll memorize the value. As we go to the right, we can see the output level of the signal generator, and it also has adjustable increments. It also has 6 memories for levels that you might want to have quick access to. If we go to the right, you'll see we have the RF output on and off control. When you turn it on, the box on the left turns red. Right under that is a VCO control. Normally, I'd say leave the VCO always on, but if you need to save some power and you're out in the field with some batteries, you might want to turn the VCO off when the RF is off. On the bottom left, we're dealing with the time base, and that is using the internal reference or the external input if you have a GPS discipline clock. Under that in the boxes is actually turning the output off and on. Your last choice is the performance mode, and that's in the center on the bottom. You either choose low noise mode or low spur mode. With low spur mode, we're turning on the dithering inside of the synthesizer, and that means that it reduces any spurious responses at the cost of raising the overall noise level on the signal. If you want absolute lowest signal noise level, you're going to choose that low noise mode and keep the dithering off. As a convenience, if you have a mouse with a scroll wheel, you can place your cursor right up top in the frequency or power output values, roll that scroll wheel, and change the values according to the increments you've set under the power and frequency. Also in this same area, you can use your mouse to click on the RF output or detector in to turn these on and off. The next tab is our modulation page. Let's take a look at all the options available to us from left to right. We've got 4 modulation selector boxes on the top left. The first box is used to turn your modulation off. The other 3 refer to our 3 general modulation options. Plus we can put sine wave modulation on the external FM input BNC connector. Using the internal square wave generator or an external square wave through the auxiliary input are very different than using an external sine wave to create an FM signal when you're using the FM input BNC connector. Using the auxiliary input or internal square wave modulator, you're creating FSK or frequency shift keying signals. Let's take a look at all the types of signals we can create. With square wave modulation, you can shift between 2 frequencies and for 2 different durations on each frequency. You can also shift between 2 output levels, also for different durations. And you can shift frequency and output levels for different durations. You can do bursts of a signal, turn the signal on for a duration and then off, and you can control events by using a trigger voltage on the auxiliary input, or use the modulation scripting language. Looking at our first pink configuration box, we see that we select between the auxiliary input, which is the external signal, or the internal square wave. We put in the frequency of modulation we desire and a duty cycle. Of course, this normally would be 50%. At that point, you're going to see that it calculates the amount of time of the wave, actually. If you put the time duration in, it will calculate the frequency. And then under that, we can do it continuous, or we can do it for a certain amount of cycles or a certain duration. If you're changing the level of the signal by this frequency, there's a minimum of 31 Hz and a maximum of 25 kHz modulation frequency. On the green frequency modulation box, you're allowed to have a plus or minus offset during the low part of the cycle, and you can put the amount of offset in the bottom box. The blue level modulation box underneath allows you to attenuate the signal by a number of dB or to maximum signal attenuation in the low part of the cycle. Once you put in your frequency and modulation values, you'll see a representation of the wave in the bottom yellow box under modulation waveform with all the signal's particulars. Third is a CW beacon, and it uses Morse code to send out a beacon message on any frequency at any level that the generator is capable of. By clicking on the message icon, you can store up to 256 characters with spacing, and it will be stored inside the unit's memory. In the yellow box, we can see message pause CW pause. Message, if we click it, plays the message. If we would like to have a pause after that, and then a continuous carrier for a while, and then another pause, and then go back to the message, we can click all of these boxes and fill in the times in the right. If we look at the blue box with dit time, intercharacter, and interword, dit time actually dictates the words per minute speed of the CW message. Intercharacter and interword give you the spacing between the characters and the words. Now normally we would just be keying the carrier on and off from the signal generator to its full power output and down to maximum negative amplitude. But with the little green box, you can decide to bring it down to a set amount of attenuation during the off period. And the fourth is a modulation script, a small programming language that allows you to set up a very custom modulation scheme. Remember, a modulation script is not a control script. The modulation script language is a small set of commands which are normally used to set up data signal preambles and custom codes used to test a particular device under test, which requires a specific code sequence. The prefix, data, and suffix scripts refer to files created to create these custom data sequences. The only two commands available are TX on and TX off with an N after it. That's an integer that's a multiplier of the time you set in the box on the menu. Now this is a text file written in all lowercase letters outside TPI-Link program, say in the Notepad editor on Windows. This allows you to handcraft any data sequence which is particular to your device under test. Lastly, on the bottom right of our modulation script column, you can see that you can run your script continuously or run it once or a number of times. Right under that, you see we have a selector for incrementing the frequency after each run. Now imagine you wanted to test how much off frequency your device would respond to its preamble. Well, you could increase the frequency by a given step and scan right by the actual operating frequency of the device and see how off frequency the device would decode the preamble. Remember that the entire user manual is available all the time with the top right user manual button. If you look on the top right, right under the user manual, there's App Note. And if you open this up, it's a PDF document with great detail about the tab that you're on. When using frequency modulation, you should click that Enable FM. Otherwise, that VCO will try to mute due to the excursions caused by frequency modulating the carrier. The external levels can go up to 10 volts, and that results in quite wide deviation. The next tab and control page is Scan. These controls allow you to scan between two frequencies at an increment and speed you set, or scan between two output levels at an increment and speed you set. And you can choose between a forward or reverse, triangle, or sawtooth patterns. We've set up a typical example of a scan we might want to do. How about a straight sawtooth scan going from low to high frequency? We're going to go ahead and click sawtooth, step up, and then put our high frequency in the high frequency box. Put 200 megahertz in this case, and low 100 megahertz, making the center frequency 150 megahertz. That's a span of 100 megahertz. Now, how much do we want to step frequency each time it steps? We're going to put in 1 megahertz here, and we're going to put in 100 milliseconds for the time between each step. And that's going to result in a total scan of 10.1 seconds. Now right now we could just go ahead and start the scan by pressing the green scan button on the bottom left. We can pause that at any time or stop the scan right here. This time we want to do a scan, but between two levels. So first we're going to go ahead and select Step Level By over here in the Scan Control Scan Type. Originally we had frequency, now we're going to do level. Then we go to the bottom left, and this time we're going to use that same sawtooth waveform, just going from bottom to top, stepping up, and let's fill in our boxes of levels. We want a high level of 0 dBm, a low of negative 70 dBm, and that puts our center level at negative 35 dBm. And that is a level span of 70 dB, bottom to top. Now if we go back up to our top right box, and we set that we want to do 1 dB every time it steps, and step every 300 milliseconds. That's going to result in a 21.3 second scan. Instead of specifying the step scan rate in milliseconds, you can just go ahead and put in the total time that you'd like the scan to take in this box here. You can also fit a frequency scan to a number of specified seconds. Now we've just got to choose whether we want it to scan once, or scan continuously, or a particular number of scans in this box here. If you'd like your RF to automatically turn on and off when the scan starts and ends, just click the RF output auto on-off box here. Remember that because we have sawtooth step down selected in our frequency function box, we're going to do a frequency and level scan at the same time. So if you want to do just one scan, level or frequency, be sure to turn the other one to none. Next is our Analyzer tab and page. Now basically you can scan from one frequency to another frequency at a fixed level. Now this is used by taking the RF output, putting it through your device under test, and then coupling it back to the RF input. And we could typically use this to test filters, amplifiers, coax, and antennas. With just the unit's RF output and the RF detector input, you can test the forward power curves through a device under test. But if you use a directional coupler, you can also test the reflected signal coming back. First we'll select our x-axis to do a frequency scan. The page is going to come up with a default forward and absolute mode scan. We're going to be measuring in dBm, and we fill in the values in our x-axis window. That would mean the start frequency, the stop frequency, and then you'll see the center frequency and the range of the span that you're going to be measuring over. You can put in how many points you want to sample at and the dwell time at each point. You'll see under the green box that you can choose between absolute, relative, insertion loss, or VSWR. Remember that these scan frequency values are not related to the ones you put in under the Scan tab. You'll see that under the start and stop buttons you have two little clickers, continuous and auto RF out. Continuous allows you to sweep through the frequency range continuously, or once when you don't have it clicked, and the auto RF out will turn on and turn off your RF at the beginning and end of the sweep. When you place a device under test, you're going to connect it up with a cable, and that cable is going to have its own response curve. What we'd like to do is plot the response curve of your connecting cable and then delete that from the final results for higher accuracy. What you would do is take the connecting cable and connect it from the RF output to the RF input and plot its response curve. You can then save that, and when you perform your actual test, you can use the relative mode to subtract the curve of the connecting cable from the device under test's plot. If we close the X-axis control box, we're back up at the top of the main selection menus. Now let's choose the Y-axis. Here you see you set the maximum and minimum dBm for the Y-axis on the left side of the screen. On the top you can see that external attenuation has an adjuster box, and this is say if you're testing a device that requires you to put an attenuator pad in between our TP-1001 and that device. This will numerically compensate for that attenuator pad. There are two other checkboxes in this window. First is Auto Scale, and this fits the Y-axis to the plot itself. Then we have Expand Only, and this will adjust the minimum and maximum dB if needed. Closing the Y-axis menu, the next selection is Save, and here we can see that we can save in two different ways. One is to save an image format in PNG or another file format, when we can decide to start the numbering back at 0 or copy the image to a clipboard and export it to an external image processing program. On the bottom, we can decide to just save the data, and we get to choose the frequency step, the points to measure, and the end frequency. Next in the lineup of our options on the Analyzer page is the cursor. Here you can move your cursor to any place along the plot and get the exact numerical values of that point on the plot in the little yellow box above. Our next selection on the Analyzer page is Memories, and this is where you can scan up to 4 different Y-axis level plots and then show them simultaneously on the screen. Note that this is not for X-axis frequency scans, and if you do change the frequency of your scan, it will erase these temporary memories. So say we're comparing some bandpass filters. We go ahead and do our first scan. We then click on Trace in our first memory to store it. Note that the active trace you're doing now is separate from these 4 memory channels, and its controls are on the top level. We would then put the next bandpass filter we wanted to test in line and scan it. I'm showing this one with the cursor feature on. We then click on Store Trace on our second memory channel. As you store them, you'll see the type of scan you've just done in a single letter just to the left of the Store Trace buttons. I already have all 3 traces stored in my memories. You then repeat this process for the third and fourth channels if you need to. When you click on the Show buttons on the left, it will go ahead and display any of the 4 memories that you have saved traces into. Remember that the current active trace of the last one you've just done is sort of like a 5th memory, and if you click on Trace, it will show that one as well. Our last selection on the Analyzer page is Markers and Grid. The main selector area allows you to see which numerical values you'd like to see displayed along your plot. Here we've selected to have the peak and down 3 dB values displayed for us numerically. You can change the text label size and colors with the other selectors. With these 2 selection areas, you can control the grid and traces color and size. The last control to mention on the Analyzer page is the Shade control. There are 3 drop-down color selectors for the maximum, minimum, and trace colors, and also by moving the shade slider, you can do the transparency of the fill. A couple of great new features that have been added in 2018 are the ability to save your scanned plots from cabling that you use often. So we go ahead and do our scan with just the cable and a barrel, say, drop down the menu here, save it, name it of course, maybe we'll just call it file name 123 for now, and you can go ahead and load that back up later if you, like most people, are going to use the same patch cables or directional coupler arrangement in many different tests. You can also erase a display, which is nice. So say you're going to just pop in a new bandpass filter or antenna to test and use your stored reference plot. Next, we're going to talk about our main control scripting in TPI links. This allows you to create, save, open, and test fairly complex scripts to run the TPI-1001. Let's first take a look at all of the commands that you have at your disposal. We can turn the RF on and turn the RF off. We can set the frequency of the RF over the entire range, and we can set the incrementing of the frequency by a given amount. We can set the power level across the entire range of the generator, and we can set increments of the RF power level. We can set it to wait for an operator to click to continue. We can set, of course, a pause of up to 60 seconds. We can have the computer beep through the computer speaker. We can set a RF frequency preset, and we can set an RF power output preset. And also we can set the trigger output on or off to trigger other equipment on the test bench. Let's take a look at the sample script on the screen now. We can see the set frequency is 915 MHz. The power is set to -10 dB. The RF is then turned on. It pauses for a quarter second. Then the frequency is incremented by -2 or decremented. It pauses for another quarter second. Then the frequency is incremented by 2.5, and so on and so forth. Remember that you can run this script with the unit on a battery pack without being connected to a PC by configuring the programmable button on the unit. The last tab and page on the TPI-Link software is the About tab. So let's take a look at what we've got here. You'll see right under TP-Link here that you can see the version history of the software or download the latest version of the software. Also, you can email bug reports or suggestion features to Phil Carlson, who writes the software. If we open up the system information, we can see the user's name, computer name, the architecture of the PC you're using, and the operating system. If we open up the Documents section, we have the user manual, how to upgrade the software, and a rich selection of app notes. When we open up the Options button, we can see that there are some general settings that are actually just personal preference of how you want to interact with the program. Would you like to show some hints when the mouse hovers over a button? Or would you like to show transitions? So experiment with those, see which you prefer. Although this software will run all of the models of RF generators made by TPI, we can see that the TP-1001 selections, which are particular to this unit, are now showing because that's the unit I'm connected with. It is possible to run multiple TPI signal generators simultaneously by running multiple copies of TPI-Link. If you've changed the settings, you'll see a red asterisk at the top right of the screen. Click on it and confirm yes to burn these into the non-volatile memory in the signal generator. You can also set the preferences to auto-save the configuration when you close the program. Remember to call or email with any questions you may have about the TPI series of RF signal generators, and check the website for more informative videos on these products. Thanks for watching.